Hello and welcome to my YouTube channel. This is Dramani Online Mathematics, and today we are going to look at selection with replacement. It's also under probability. Selection with replacements. What do we mean by selection with replacements? But before I start, I want to say this. When you watch the video, try to subscribe and share to your colleagues. Selection with replacement simply means that selecting an item from a lot and putting it back from where it was taken. Is that okay? So, let's assume that I have this. Then, I have 3 balls here, 3 blue balls, and 4 black balls, okay? So, with 1, 2, 3, 4, let's say the sample space will be 1, 2, 3, 4, 5, 6, 7. So, our sample space will be 7. Is that okay? Now, getting black balls will be 4. Then, number of red balls, blue balls, let me represent that one by R, is 3. Is that okay? Now, if I want probability of selecting the first ball to be, let's say, black. So, first ball is black. And second ball too is black. Then, the probability is going to probability of selecting the first ball to be black times probability of selecting the second ball to be black. Now, in this case, probability of selecting the first ball to be black will be, so here, when I take 1 from it, that's going to be 4 over the sample space, which is 7, times the next one will also be 4 over what? 7. Is that okay? What you are saying is that if I take the black ball from it, I put it back. So let's say if I take it, after using it, I put it back. So the numerator here will maintain, the denominator will maintain. That's the sample space maintain. The same thing, the event there will maintain. So even if you are to take first ball to be black, second ball black, third ball black, you will still get 4 over 7 times 4 over 7 times 4 over 7. Because after taking it, you replace it back. Or if the first ball is black and second ball is red. So example is, if I have first ball, probability that the first ball, let me write this way, is black. Intersection second ball is red. Then I'm going to have first ball is black, so 4 over 7 times 3 over 7. Is that okay? Very good. So, now let's also look at some example of this. Let's look at the first example. A bag contains 4 red balls, okay, and 6 black balls. A ball is selected from the bag, after which it is replaced. So after selecting the ball, you replace it. A second ball is selected. So first ball was selected, and then the second ball was also selected and also replaced. What is the probability that both balls are red? Is that okay? So we want the probability that the first ball you picked was red, the second ball too was red. But remember, they were all replaced. So now, let's put some information down. You can say that let's R equals to red balls. Then B equals to black ball. Now, means that number of obtaining red balls is going to be 4. The number of obtaining black balls was 6. So our sample space is going to be number of obtaining red balls plus number of obtaining black balls. The number of obtaining red ball is 6 plus 4. Is that okay? Very good. Now, the question is saying that I should find probability to obtain the first ball to be red and the second ball to be also red. And we all know that this one means what? Intersection. So I can write this one as probability of first ball red, intersection, second ball red. And that one, we use the formula probability of obtaining first ball to be red times probability of obtaining the second ball to be red. So probability of obtaining first ball to be red. Obtaining red ball is 4/10. Okay. Now, when you are taking the second ball, because it was replaced back, you will repeat it. So that one too will be 4/10. Is that okay? So from here, you can see that probability of obtaining first ball to be red, intersection, second ball to be red, will be 16/100, which can be written as 4/25. Is that okay? The explanation here is that because it's with replacement, if the first ball is red, second ball is red, then it will be 4/10 because it's replacement. So after picking the first one, the second one will be the same thing because you will replace it back. Is that okay? Look at second example. A bag contains 4 red balls. A box contains 4 white balls, 3 black balls, and 2 red balls of the same size. So let me write them down. So number of white balls. Okay, first one is white. White balls is 5. Then number of black balls. Number of black balls is 3. And number of red balls is 2. Is that okay? So first thing, you need to know that sample space. That one is very important. So the sample space is when you add all this. And if you add all this, you get 10. Okay. Now let me continue with the question. So the question says a box contains 5 white balls, 3 black balls, and 2 red balls, okay, of the same size. A ball is selected at random from the bag and replaced. So here too, we replace it back. So whatever you take, you replace it back. Find the probability of obtaining A, 2 red balls. So the first one, you should find the probability of obtaining 2 red balls. So they want us to find probability of obtaining the first ball being red and the second ball being red. So that one, the formula becomes probability of first ball red times probability of second ball red. Is that okay? So in this case, probability of first ball being red, you see, red is 2, so that will be 2 over the sample space, which is 10, times second ball, because you are replacing it back, you maintain it, so 2/10, which will give us 4/100. Is that okay? And 4/100 is same as 1/25. Very good. So that is the first one, or the I. The I said 2 white balls. So we want probability of obtaining 2 white balls. So let's see. The first ball is white, okay? And second two is white. So this one is going to give us probability of obtaining first one to be white times second one to be white. Now probability of obtaining first one to be white, our white is 5, so that gives us 5 over 10 times 5 over 10, because it's with replacement. 5 times 5 is 25 over 100, which give us 1 over 4. Is that okay? Then I said two white balls or two black balls. So probability of obtaining two white balls, that means you get first to be white, intersection, second to be white, or two black balls. So first to be black or second to be black. So if you want something like this, first to be white, second to be white, that one we have already done it. We had 1 over 4. All means plus, so plus. First to be black, second to be black, that one I have not done that. So black is 3, so you are going to have 3 over 10. This one is intersection, okay? Times 3 over 10. So 1 over 4 plus 9 over 100. And when you do the calculation, you are going to have 34 over 100. So this is the solution to the question.